Welcome. My name is Hassani Ali, and as part of Duke University's Managing Machine Learning Projects course, I'm going to present a proposed machine learning project to predict disease of the pancreas resulting from Glucagon-Like Peptide 1, commonly known as GLP-1. I'm going to go over what glucagon is, opportunities for machine learning, success criteria, data source, validation plan, the machine learning system design, and potential risk in production. So what is a GLP-1? Well, it's a medicine that supports insulin excretion, which can be non-existent or ineffective in persons with type 2 diabetes. The benefits are weight loss, and it does this by delaying digestion, gives the patient a sense of fullness. Also, it promotes better heart rate function. There are many drugs out there. Wegovy is one of those that have been approved by the FDA for weight loss. Trulicity, Ozempic, Rybelsus. And next to each of those, you'll see the active ingredient. For example, Wegovy is semaglutide. But there are side effects, such as pancreatitis and pancreatic cancer. And so the need for GLP-1s. As you can see, the map on the left-hand side shows the obesity levels in the United States. And for some states, it's way over 40%. So the darker, going from yellow to dark red, increases the percentage of people in that state with that are overweight or considered obese. If you look over to the right-hand side, you'll see diabetes trends, which are on the up, and they have been up on the upswing for years. And there's a high correlation between obesity and diabetes. For example, 89% of the people that have diabetes, they're also have weight problems. And diabetes is not the only issue that comes with being overweight. Is, for example, heart problems also. So what are some of the opportunities of doing this machine learning project? One is understanding patients' proclivity to have pancreatitis, pancreatic cancer, and thyroid cancer, and a whole list of other side effects. Provide an alternate approach to weight loss for high-risk patients that are identified at risk for significant side effects. Also, reduce the costs incurred from remediating significant side effects of high-risk patients. So for example, if by using a GLP-1, a patient gets pancreatic cancer, well, there's a cost to that. The stakeholders are doctors, corporations, government, patients, and insurance. So we want to predict if a patient will get significant side effects, namely pancreatitis, but this project can be expanded for other kinds of issues from using GLP-1s. Now let's talk about our success criteria. The number of patients that incur significant side effects is reduced because hopefully this project will create a model that identifies potential persons that may be affected, adversely affected. The cost associated with remediating significant side effects caused by GLP-1 is reduced. So for example, if a patient gets pancreatic cancer, there's a cost with that. And finally, the accuracy of our model is greater than or equal to 80%. So, an 80% accuracy rate. So let's talk about data sources or potential data sources. There's a 4-pay IQVIA database, also the Food Drug Administration. So we'll have to do some research to see if we can get the data from there. we're looking for demographic data and health data. And this data, there's lots of privacy concerns considering the data, and also proprietary data that companies may have, that we may have access to. So some of the data concerns are limited data. FDA recently approved GLP-1s for weight loss, and more are coming online. So as the rate of GLP use increases, there's going to be much more data. It's increasing exponentially right now. So data skewness by demographics. Also, wealthier patients may have access to the GLP-1s, whereas poorer ones may not. And insurance companies many are not willing to pay for weight loss by GLPs right now. Selection of the feature set could be very large. And also correlating the data with the target. So we have to work closely with our stakeholders. Semi-cold start, possibly with the onset of many more people using GLPs, the data will shift. We'll address that in a later portion of this presentation. So now let's talk about our validation plan strategy. It's to work closely with the stakeholders to refine our decision and framing of our problem. Also is to ferret out the data set. The data set will probably be large, but it's to keep the feature set as small as can be, at least initially, and maybe one target, or reduce the number of targets, limit the number of targets that we are aiming for. Also using tools on the marketplace like SaaS Enterprise Miner to quickly create models and compare models. So we could do a logistical regression, we could do forest, etc. So SAS allows you to do that quickly and gives you lots of data, and we will repeat that multiple times and demo that for the stakeholders. Now let's talk about the machine learning system design. So our use case is to predict if a patient will incur pancreatic cancer or a significant side effect from using a GLP-1. Our requirement constraints are assumed connectivity, large volume of data. There are privacy concerns with the data. It should be anonymized. And the system design is in the cloud. It's not something that needs to be in anything close to real time. Offline learning and batch processing. Figure with the learning, could be months or multiple months. Let's talk about potential production risks. One is rapid growth of data, the volume and velocity of the data. More people are using GLP-1s today, and it's increasing exponentially. Insurance companies are hesitant to cover GLP-1s for weight reduction, but that will probably change in the near future. Currently, the cost of these GLP-1s without insurance is $1,000 to $1,400 a month, which is prohibitive to many people. But if that changes, the number of GLP users will increase significantly. Also, the FDA is approving more GLP-1s. The source of the data, source data access and consistency is also a concern. Incorporating new diseases. As more people use GLP-1s, the model may have to change to reflect the additional features that may need to be added or changed, transformed, and also target. What are the targets that we're looking at? And finally, new ML models may be required to address all of the above, the growth and the consistency data and new target data, new features, etc. That concludes the presentation. Thank you.